Welcome to Repair Cafe Godalming tutorial. This is a tutorial on the strip down of a recent fix. Well, it's not a fix, as you'll find out. Enjoy. Welcome to a Repair Cafe video. This Repair Cafe video is really sponsored by the Repair Cafe Godalming in the United Kingdom. We are a Rotary Community Corps and we meet monthly, apart from December. And I'm going to take you through the disassembly of a device that's really frustrated me. Why I'm doing this? Because I couldn't find anything on the internet. So I'm doing this for obvious reasons. So what is this thing? I have got one of these. It is a Salter. What's it called? Where's the product name? We'll have a look at the product name. Oh, it's a 3-in-1 blender set. There you go. 3-in-1 blender set. Whisk chop. It was brought in, didn't work. Don't know why. Excuse the cable. This is it. Can I disassemble this? No. Almost impossible. So I'm going to disassemble this slowly and we're going to see the destruction of this. Why I'm going to destroy it, because I've spoken to the owner. She says it's okay, I can't get in there. Well, I've sort of got in there a little bit and that's frustrated me. So I'm actually going to complete this disassembly so that others don't have to wreck their next one. Or maybe not. Maybe I could never get this apart. I don't know. But this is a Salter blender. What I did initially, I popped off the two ends here and we took this out here. This came out quite easily. It's in my hand. Gone. It revealed it just doesn't operate, okay? And there's a really simple switch in here, and there's a PCB and other things. Doesn't power up. It's clearly not the fuse, and I can't even check I checked the continuity between the plug here and its contacts in here to ensure that the wire wasn't broken. So it wasn't that. So I had to get inside it, and that's where the fun started. So I will be stopping and starting the video, so you'll see the clocks and time will change, but I'm just going to go through. So I am going to recheck the continuity between the plug and the actual PCB inside of here for both the live and neutral. Let me just check that. Hopefully you can hear in the background my continuity tester. I'm on my bench here. Okay, let's just check the live. Checked. Neutral, good. So we now know that it's not the cable and it's not the fuse. I'd actually check the fuse straight away. So what do I know already? I know that deep inside of here there's some clips. There's a clip here that is 75 millimeters down. There is one clip. On the other side there is another clip. So I managed to get those out only by, and then it sort of forces the plastic here. So what I'm going to do is I'm going to figure out how this comes apart. I believe that this ring here holds the assembly together. Now this is the what do you call it? It disconnects the accessories. These two buttons here, but there may also be a ring in that this ring here may also retain this bottom part. So even if I force the clip here, if that is retained in here, there's a clip here, and we'll assume there's another one here. I would imagine if I was designing this, I'd put a clip here and a clip here, and then use this ring. But I don't know that. Now, it's very hard for me to push this in, these two buttons in here, and retract this ring. Hence, I'm going to destroy this ring on this test here, see what's inside there, so others coming this way can then work out a method of pushing these two buttons in here and extracting that collar. So I'm going to take this and I'm going to somehow get in here. Don't know yet, but I'm going to stop the video and go and do that. End of that phase. This ring is now removed. So that is retained by pushing these two buttons in. By me destroying it, I can see how it works. So the only way to get this off is by pushing these two buttons in here and retaining them in. I don't know how you're going to do that, to be quite frank. The way that this is manufactured, it's aligned, there's a slot here. So they must assemble it. When they assemble it, they must assemble that like this, push those two in, and then slide the ring back. That would make sense. So to get that off, you're going to have to push these two in, maybe with ball bearings in a vise, or something that is the same diameter as this. Push those two back, and once it's pushed back, the moment you can slide that forward, I think you might be able to get this ring off. Okay, because the moment you can move it a little bit forward, then you'd be okay to get it off. Is it tapered? Let me see what's retaining it. There's a clip, not a clip here, but there's a ridge, and that ridge sort of concerns me for disassembly. Let me have another look. Even now it's hard to get it off, even though it's broken. Sorry, the wrong way around. I have to align it properly. Get it on there. Yeah, there's a ridge here, which I think would make this next to impossible to disassemble. Try the ball bearing trick on here and then sliding it off. It may work. Now, however, I can't see any clips in here. It's solid. So I'm going to go away and figure out where those clips are. Well, that was easier than I thought. Okay. Splodger blade. Now look, when I was trying to get in here yesterday, it's damaged the casing. So getting this off is extremely difficult. But the clip is, I'm going to measure it. One moment, I'm going to get a measure. You're going to like my measure. The clip is 2.5, 2 and a quarter, so that is 60 centimeters down. We'll measure it perfectly in a minute. I might even find some verniers. Right, where's my tool gone? Okay, so I've removed the ring by magic, obviously destroyed this one, but in the future, and look, it just comes apart because there is only one clip, and that clip is exactly here. The moment you can release that clip in there. Now I did actually manage to get a screwdriver down here yesterday to release the clip, but look, it's coming apart in my hands now. Look, one clip, and let me measure that for you so that we know exactly where that is. Okay, got some verniers. The clip is 62 millimeters from the top there, from that edge. 62 millimeters from here. Let me have a look. Now that clip, interestingly, is a broken. Now that might be because I've had it to pieces yesterday. Oh look, there's a piece of plastic here, which is the edge of the clip, which is not good. Motor comes out in my hand, motor controller, the ejector, all coming out in my hand, and some screws in here, which I am now going to remove to get the PCB out. Then we can actually look at the fault. I have a very nice set of RS tools, super drives, and a guy called Ray worked for me once, and I said to Ray, go buy some tools so that you could do some work for me. This I'm talking here in the 80s, 1980s, and he bought a very nice tool set. Unfortunately, I laid Ray off, got made redundant, and I ended up with this toolkit, and I've still got it this very day. Now, oh, this is interesting. So there is a tucked away, and I could not get at this. Trust me, from the end, there is a fuse. The question would be, why has that fuse blown? Obviously, I'm looking for my zoomy thing here, so I can zoom in for you. By the way, I do videos on my other channel. There we go. There's a fuse here. This is, look, the switch. The switch is really basic. all it is, right? Okay, power comes in, you turn the power on. That's a boost mode, whatever. This is a diode, could be the diode. There's a fuse, and there's a capacitor. And what's this? Some sort of smoothing capacitor for the motor. Yeah, there we go. That looks like a, yep, that is a, so what we've got is AC coming in here into a bridge rectifier. Bridge rectifier is then smoothed by this capacitor here. Could be that capacitor, but probably this fuse, which you cannot maintain. So I'm just going to get my bench. That still works. Oh, dear, that's a bit of a concern, isn't it, eh? It's not the fuse. So we know the live comes in here. I can see that. Live comes in here, a bit of reverse engineering here. It comes down a rail here into this capacitor, into the bridge rectifier, and I'm going to see if the capacitors are blown to see if they short circuit. No, that's not short circuit. I'll just get out of the way. I'll just check the diode. Oh dear. Oh, you can't see. The diode is probably for reverse protection. No, it's fine. It's fine. I think it's the bridge rectifier. That is tatty. That is tatty if it's the bridge rectifier. Let me just see if this capacitor short circuit here. Oh dear. That looks like it's a bridge rectifier. Okay, I am going to disconnect this bridge rectifier just to test it. Before I go and take the bridge rectifier out, I just want to show how cute this is. Look, there is a very good design to this board. Look, this is the live signal here. Look, this is to stop it all shorting out. Look, there's a huge gap here, which is a safety regulator rail, and there's a second one here. Look at that. That is extremely quite clever in terms of designing a PCB. Very simple. Essentially, all that happens is that the power comes through here into the fuse. The fuse and takes it down to the capacitor for smoothing. It then takes it across there into the bridge rectifier. Let me have a look at how that works. That's the live. That's the live. There's a capacitor there. Oh, this is the input here. This is DC in. So AC in here. Yep, AC in. AC in. AC. This is the AC side. So then they've got DC signals coming out. Let's look at the specification of the motor. That's a DC 220 to 240 DC motor. So all it's doing, otherwise the motor wouldn't. You'd have a more complicated assembly. We could find out if it's the motor. Be disappointing, but maybe that's what I should do. I don't really want to have 240 volts when you're in my workshop, to be quite frank. Look, that might operate at a lower voltage. I'm going to try this at a lower voltage to see if it's the motor. It's not the motor. I put 30 volts DC into this, operates fine. Okay, so we know it's not the motor. Put that aside. Here's the PCB. Here's the PCB back again, but less the capacitor, and I have removed, which I had not incorrectly spotted, a thyristor. Okay, why have I done that? I want to isolate this. So I've taken the motor off. This is the thyristor. The blue one is the thyristor. Actually, I can test that. I'm going to have a little test thing here. I can pop that in there. Push the button, testing it. 29 PF, that's good. That's acting like a capacitor. This is not short circuit. Oh, that's fine. So that's not busted. What have we got here? We got a bigger capacitor. This is a larger. I don't believe it's this because why don't I believe it's this? Because I did test this. You can test this in circuit. Let me just push that into here a little bit. There we go. I just need to get it into my ZIF socket, and that says that's 200 nanofarads. Hey, guess what? That says 200 nanofarads. So that's good. It's all pointing towards this, which is a bridge rectifier. Not bridge rectifier. Is it a bridge rectifier? Well, to look really. I didn't look at the part. Let's have a look what part it is. Move that out of the way. I've got a very large bench here, haven't I? Just so for those worried. Look at that. It's a KP310. I'm off to the web. Back in a bit. KP310. I see. Ooh. Ooh. I'll just pause the video. So interestingly, this has got an edge on it, a directional edge, so that will help me in my search. And over on, let me go to my desktop, over on the web, I have found the part, as I expected. It's a bridge rectifier. It's this particular device here. Did I actually get that wrong when I looked up the device? Oh, KBP310, which is this one here. So it is a KB. I'll get it right eventually. B diode. There we are. Plenty of them up on the web. £2 to replace it. It's I want the data sheet. It's £1 lot. So cheap. I think that's what's wrong with it. I want the data sheet. Why do I want the data sheet? I'll show you why in a moment. Let's go back to all. KP10 data sheet. There we go. So I want to look at the internal circuitry. Well, yeah, fantastic, eh? Isn't it brilliant? No internal circuitry on it. Back to the images. Isn't it brilliant? I'm going to try and find some circuitry. Oh, there is one there. Look. Okay, great, found one. It says the following. It says that there's a positive. You've got DC coming in on 2 pins here, and then you got a positive and a negative. So it's just a standard bridge rectifier. So I should be able to test that. And because I removed those components, I did that on purpose. Oh, I should go back to the camera. I removed the capacitor and the bridge rectifier. The thyristor on purpose because it's isolated this. I can now test this in position. I don't have to desolder this. So I'm just going to test that to see what happens. So I did the test across the bridge rectifier. The bridge rectifier is Almoto. Now I'm just going to look on here for damage on the bridge rectifier, looking to see if it's had the magic dust, the magic smoke come out of it. No, I can't see any damage on it, so I'm just going to extract it anyway. I'm going to put it in my special little box I've got here for testing components. First of all, this is not what I thought it was. This is an MOV, which is a device for overload protection. It's not that. We know it's not that. I checked that with my little box here. And guess what? El Moto, it's dead. So the issue is here. It has AC coming in and no DC coming out. This is not repairable by man. So what have we learned? Let's have a look what we've learned. We've learned that to disassemble this device, you've got to take the collar, the the ring off, wherever the ring is, and you slip the ring off. I believe you can do that by pushing in what was here, the indents here, and then this ring will slide off. Once you've done that, there's a clip, 2 clips, 60 odd millimeters down here. Is that correct? Is that what we said? Let me just check that with my, it says 50, but it's in the 50 to 60. Oh, we can measure it properly. There's a clip here, and that is 60 millimeters from the top, 62, I believe. There we go, it's there. Then it gets it into 2 pieces. You can then get out the PCB, and by taking off the 4 screws, then you can check everything out, replace things that are necessary. Look. Not really repairable.